Hello friends, today we are gonna actually discuss about a small game that look like this. This is a small game in Snake and in the language Python while using a library called pygame, and we have developed this with a very simple logic and in lesser than say about it is around 150 lines. Just there are just blank lines which are actually being counted, so it is actually showing 160, but it is actually lesser than 150. So it is actually a small game with a simple logic. So let's actually discuss what's the logic behind this game, right? So here we have imported the pygame, which will be used to actually set a screen for our game, for our canvas element, and then we will get a reference to that screen with this pygame.display.set mode function, which actually sets the width and the height of that game. Means we are wanting a width and height of 400 by 400, but we are also wanting a 40 gap in the top like this one. We are also wanting this gap to actually display a score, so I have kept it to be 40, and after that it is actually a square of 40 by 40 pixels, 400 by 400 pixels on. And then we will actually discuss each and every part of this game one by one. Firstly, we will discuss this loop. This is actually a while not done loop. The done is actually a variable which is actually set to say false, or the done is actually set to true whenever we want to quit the game. Like for example, if we can actually traverse all the events which occur on the window of the game by this loop for event in pygame.event.get, and if the event.type is equal to pygame.quit, it means that whenever we press something like this cross button on the game's window, like if we will press this cross button here, this close button, then this event will be triggered up, and here this will be fired up. And if it comes out to be a quit event, then we can set the done to true, and due to the not loop it will become false. When done will be actually set to true, it will become false, and the whole loop will stop running, and then means game will end. So, what about the game? What is actually happening in the game? In this game, we are actually having just a single piece of, say, rectangle, or it's a single piece of block which needs to be actually moved on. And about its tail, it is actually its previous position storage. So that's actually the basic logic of this game. Let me give you a brief intro that how we have to actually play this game. So if I actually close this actually being in the over state. So if I again run it, python snake.py, and then it will start running up. So yes, it is running, and this is actually showing a long tail because I have actually set it the tail length to be 10, and if I set it to 1, then tail will be nothing and only the head will be shown. You can see that the snake is moving around the screens and going from the next thing. We will discuss all the basics behind it, that how to implement this logic. And whenever it actually eats the food, it actually increases its size by 1. And whenever it eats itself, then game gets over, and it starts printing game over here. So let us discuss. Firstly, we need to keep a track of a single block. And before that, we have to actually divide the whole screen into say blocks. So if we have a screen of 400 by 400, then what we have done is actually divided it into say 50 sections. Means in a screen like this, there are 50 blocks around there and 50 blocks around here. Means 50 cross 50 blocks. Okay, and one block is actually used for presenting the snake, and similarly the same size block is actually used for printing the food of the snake. Okay, so we have also kept a reference of the pygame.time.clock into the clock variable, which will be actually used to actually set the frame rate. In the python we have simple settings for actually setting the frame rate. We have a tick function which is actually a reference to the clock object, and the tick function actually sets the frame rate of our while loop, means of our game loop. Means the internal game loops have their logics inbuilt, and we have to just give the as a parameter that how much the frame rate needs to be. The frame rate is actually the number of frames to be run in a single second. Means 6 we are passing here as 6 as a value, so it means that we need 6 frames per second. Okay, so Now, what we will do if we want to actually print a single block, we have kept the position of x is equal to 0 and y is equal to 0. And then what we want to do is actually print those position in the while loop. So with this command, that is actually equal to pygame.draw.rect, we can actually draw a rectangle on the screen. So what we have done is actually we have printed pygame.draw.rect, and then on the screen is actually what was the reference as what was actually referencing the screen with the width and the height as attribute. So we can use this as the first parameter. It will give me the surface on which I have to actually print on the rectangle, and the second one is actually the rect object, which actually takes the first parameter is actually the x position of the rectangle, the second is the y position of the rectangle, and the third position is the width of the rectangle, and the fourth position is the height of rectangle. It is actually a function in pygame, and its syntax is like this. The second parameter is actually the color with which you want to actually fill the rectangle by default, because by default it fills the rectangle. Otherwise you can also have stroke modes by passing another parameter here that's actually equal to width. So we have used this one. So it will, if we have left the game to with this statement only, then it must have printed this only at 0 0 position, means on the first block, which is actually this one, must have been printed towards this position only, and nothing else must have been printed. Then we have, what we have done is actually our logic is something like this, that we want to actually set a direction, and on each frame it has to actually update its position. The block, the first, we have to only keep track of the first block, and the next blocks will be tracked automatically by storing the previous positions of the snake according to the tail length. That's actually what the logic is, right? So I have a move variable which is actually storing two elements, that are actually 1 and 0 and 1. This is actually a list. So 0 means this is actually for the x direction, and this is for the y direction. For the initial phase, I want the direction to of the snake movement to be downwards. So what I have done is actually the x direction will be 0, means no direction to the x coordinate, and y means 1 I have kept for downwards, so it will actually go in the downward position. And similarly for the say up position, I have kept -1 in the place of y. And for the left movement, I have kept -1 in the place of x and kept y to be 0. And for the movement of right, I have kept for the movement of right, I have kept the x variable, means the first coordinate to be 1, which represents the x direction, and the second coordinate to be 0, means I don't wanna give any direction to y. The minus states that in the left right movement, the minus states this left, and the 1 states right movement. And in the case of up and down movement, -1 states upper movement, and +1 states a downward movement. So in this way they are working, and I have used the press event. The press is actually getting the events, means the key press events over the window of the Python. So I have used the Python pygame.key.getPress and kept it into a reference or variable of press. And then I have checked the press, that what has been actually being pressed. So I can use the key code. This actually, if pressed pygame.key up, this actually, the Python actually implements a multi-key input in which you can actually input two keys also at the same time. So if a particular thingy is actually on, and then you can also check for another key to be on. So press is something like a boolean array in which the key codes gets switched on. The key codes have some numbers which are actually used as indexes, and they get switched on, means they get a true value whenever the event is actually fired. So you can use this in the if condition, means if the upper key is actually on, then this event condition will be fired up, and this condition, the next condition is actually checked for checking if the snake is actually moving in the downward direction. So we can't actually allow upward direction to the snake. We can only allow the upward direction to be whenever there is a case of only left direction, or say right direction, or say upward direction. So we don't want the snake to be in the downward direction to get excess of upward movement. So we have checked the moves 0 is not equal to 0 and moves 1 is not equal to 1, means that was actually the case for what I have kept for the upward movement, sorry, downward movement, right? So if there is no downward movement like this, then I can allow upward movement. like this. I can set the move variable that will actually be used for setting the direction next in the next way. So in this way, I have implemented all. For the left direction, I have denied the right movement of the current direction, and similarly for the left, I have denied the right movement. Means for the right movement, I can't allow the left direct movement. You can actually go up and go towards left. And similarly for the right, I have denied the left movement. And then after I have just done it, this loop is for no use. I have just done it for implementing the frame rate on my own, but it is actually already available through the tick function, so I don't need to do it. And thus I have actually, on the basis of what the direction of the current snake is, I can actually increment or say update its x and y coordinates, which actually will be used to actually print the rectangle of the first means head of the snake. So if the movement of means if move 0 is actually equal to 0 and move 1 is actually equal to 1, this means the downward movement. So I need to increase the y coordinate. So here I have actually kept a track of not the pixels but actually the position of the block in which the head will be printed. So as we remember that we have 50 by 50 blocks in our whole screen of the window in which we have a game implemented. So if we will increase the y coordinate by 1, then the block will be move a bit downwards, means by one block. And similarly for this is the state of say upward movement, so we will just decrement this y coordinate. And similarly for the x1, we whenever there is actually a right movement, so I can increase the x coordinate, and similarly for the left movement I can decrease the x coordinate. Okay, so if and also I have to check for overflow that whether the snake head block goes off the screen. Means whenever x gets a value of 50, then I can reset the x value to be 0. Means so that whenever the x will get a value of 50, so the index here I have used is actually 49 for this last block, and whenever the snake goes off this last block, then it will get a value of 50. So I can reset it to the value of 0. So x will be reset to 0. Similarly, for the left side, whenever the snake goes towards the left side of the screen, then I can reset it to 49 so that it jumps up to this side. And similarly for the left and right movement we have done. Okay, so that's actually for the upward and downward. So whenever the xy reaches below the screen, means something like this, the 50th row, means y coordinate will be 50 at this position, means I will set the y to be 0 so that it starts from this place. And similarly for the upward direction, whenever y gets a -1 value, then I can actually reset the head position of the snake to be at this place. So I have reset the y to be 49. And then I have kept now this is the logic, this is the main logic for keeping the track of the tail, right? How do we keep the track? The main logic is there. We have a tail length variable which is actually created before the loop, like this. Tail length variable is actually equal to 1. Yeah, means it will keep the track of only one block for a snake, and it will actually increase after eating the food, right? It will actually increase. So I have kept the logic for the tail here. After that, resetting the position so that next position, whenever before repositioning the snake, the next time we have to actually check for the tail variables and have to keep the track of the last positions of the snake into the tail array. So I have kept a tail array here, which is actually empty, and it will be appended with the position of the snake in the successive iterations. So if the I have to check for the condition that means I have to check for the condition that whether the tail is actually containing the number of elements which are actually lesser than tail length. If there is something like this, that I need to actually append one more, means my current position, also to the snake. Otherwise, if the length is already there, then I just need to actually just shift all the things and put my current position in start, right? I have to do something like this. So what I will do is actually I have to shift my current position in the 0th index of this tail array. So what I will do is that I will put the dummy element, that is 0 0 in the tail, and I will append it. And I will shift all the elements to one place towards right in my list, and thus my first list will be a repeated entry, and thus I will insert my current xy coordinates into that place. Okay, and if there is a condition that the length is already available, means the length is already there, means I have a total number of elements in tails to be equal to the tail length. Then what I will do is I will just actually shift all the positions and just insert my current position into that snake array. Means zeroth part will be xy, and all the elements will be shifted so that my current location can become another state, another tail. Means tail's head will be actually my current position for the next iteration, and my current position will actually move a bit by one block forward in the direction which is actually be specified by the move. Okay, so now I need to check. Now I need to check keep a thing for the food, that is what is actually the food. So I have kept a food array here. Food array is actually containing the x and the y coordinate of that particular food. So in the start I have kept 25 in it for the dummy state, and food present is equal to 1, means on the screen there is food already present. Then what I can do is actually check. I have to actually check for a condition that whether the food is actually printed on the screen over the snake. So what I will do is actually I will also keep a variable. I will also keep a variable that is actually food collide, which is actually set to 0 in the start state. Then I will check for all the tail elements of this snake. Right, check for all the tail elements of this snake by this loop. Right, if I will how I will check the x position with the tails x position, and y position of my food with the tails y position, tail elements y position. And if there is some equivalence in it, then I can set the food collide to be true. Then I need to actually find another state, another random position for the food block over the screen. So how I will do it? I will do it with the while loop. Whether while the food collide is actually equal to 1, means there is a collision between the food and any block of the tail. Then what I will do is actually for the first state I will set the food collide to be 0. Then for the then I will find some random position on the screen, like food x is equal to random dot next int 0 to 49. So it will get me a number between 0 to 49 inclusive 0 and 49. And then what I will do is actually send the array to be food equal to food x comma food y. Then I will again check for the collision that whether my updated position is actually coming into the tails position. So I will check for this in this for loop, and then if it actually collides with the same condition, then I can check for the I will set the food collide to be equal to 1. And this loop will keep on running until the food collide is actually equal to 1, and otherwise if there is no collision it will be remain in the 0 state, and thus this loop will be exited, and the game logic will be continued. Now, similarly, whenever we are actually trying to move across the screen, we need to also see that whether my head of the screen snake is actually eating the food. So what we can do is actually get my head of the snake, get the coordinates of my head of the snake, and then I can actually check those coordinates to be equal with to be in the equivalence with the food x and y coordinates. And if it is true, then I can increase the tail length and also increase the score. And the score printing is the next one. So where I am doing this, and that is actually here after the increment of the tail position, I am actually seeing that because I want all the tail position to be checked with that food item. Okay, so if my food item, right, if my food item is actually being collided with any of the tail item, means the snake has already eaten that food. Then I can increase the tail length with 1 and also score with 1. And also then what about the game, what about the game ending? So game will end when we will be actually biting, means our snake will bite itself. So any of the tail element will collide with other of the tail element. Then we will actually set another variable which is actually equal to 0 to 1, means our snake bite itself is actually set to 0. So we will set it to 1, and then it will be actually set to 1. Then what we will do, I will actually explain later. So there is actually a two-way for loop in which we have ith for loop, and then we have jth for loop, which will be actually run for all the tail elements. And whenever I is not equal to j, means we are checking for the different blocks, not equal ones, because it will always be true for the equal elements, because they are already equal, so their coordinates will be equal. But if there are different blocks and then their x and y coordinates are matching through this condition, then it will be actually set to 1, that snake is actually biting itself. And then I will what I will do with this variable is I have used a if loop, if condition here in the start of this while loop, that if the snake bite itself is equal to 0, means if it is actually equal to 0, snake bite itself is actually being 0, means it has not bited itself. Then what it has then I need to actually run the loop, means all the game logic will be here. But if it has bitten itself, means if it is actually set to 1, then it will go to this else state, and I will print on the screen the what that game is over, and I will print on the screen, and I will wait for the user to actually close the whole window via the close button. So how do I print the text on the screen? Firstly, I need to actually create a text object like this. Text is equal to font dot render. Firstly, I need to actually create a font. But how I will do it? There is a function called the pygame dot font in pygame library of Python, that's actually written with the font reference font object. So pygame.font dot sys font, and then in this I will actually pass a system font. I can pass like Times New Roman or say consolas, because they are all available already on the every systems, almost all the systems. So consolas is actually passed here, and the second one is actually the size of that font. I've kept it to 30, so 30 looks something like this in the screen. And then what I have done is actually I have created a text. How I will create a text? I will create the text on the basis of the font object, font.render, and the first is actually what the text you wanna actually display on screen. Second one is actually a true variable and true parameter, and the third one is actually the color with which you wanna print the text on the screen. This color is actually for that orangish color, means that's actually pinkish orange color. And the 3 8 these are RGB values. The 3 187 and 255 are for that bluish color, right, for the sky bluish color. And these are the RGB values for it. You can actually search these values on a website. Okay, I will mention it. So this is a score text created. So score text is actually representing this text score with colon some text, some score, and then the text object is actually representing this one. A text object is actually representing this game over thingy. When we actually define the text object, which is actually this game over thingy, which is actually stored in this text, I need to actually do not update this game over thingy, but I need to update the score thing. So what I will do is actually on each iteration I will check for the score. The score variable is actually stored in this score variable here, and then I will convert it to the string, and I will append it to a score text, and this whole will be printed on the screen with the help of this score text variable. And this score text variable is actually like the same as that text variable. And I will use this score text variable inside my blend function. The screen.blend function is actually used in Python for printing the objects like text or say images onto the screen. And the first object actually represents the text which you want to print on the screen, which contains this string. The second one is actually the x position of the text, and the third position is actually the y position. So we want to print this score on the top. So I have inserted the y on the top for the top most position, and the x to be this width represent the whole width of the screen, and the x of that width represent the width of this text. So I have actually subtracted 60 from this value to actually stabilize the text to be represented on the screen. And then I need to actually also call on each iteration, I need to call pygame.display.flip, so that all the things on the screen get updated. Means whatever the updations I made, whatever I print on the screen, it is actually a double buffered library. So I need to actually call this thingy to update all the things up. Mean whatever is actually stored in that buffer via these functions will be actually updated with the contents of the canvas on the screen. So this is the whole logic. Firstly, position of the head movement of the snake will be tracked, and then according to this x and y variables, its tail will be stored in this tail array according to the previous position of the head variable or the head block. And then according to the tail length, and then we have the track of the food by this food array which stores the x and y position of the food. Then we have also tracked for the collision of the food item with any of the tail item of that snake in the, and then increase the score and the tail length. And also kept the track of the tails block collision with another tails block via this double for loop. And then what we have done is actually printed all the tail by this for loop. I have just traversed all the tail elements, means which are actually the coordinates of the tail blocks, and then I have printed ellipses on those position. Similarly, according to the similar like the rectangle printing function, this also takes the surface as the first argument. The second is actually the color. This is actually for yellow, that's why the tail is being printed with the yellow color here. And the third one is actually a rectangle specifying the again the coordinates of that circle to be printed. Firstly is actually the x1. The second argument for this rect function goes for the y coordinate, and the third one is for the width dimension, and the fourth one is actually for height dimension. This actually goes there, and it will help me print a buck or print a circle over any position. And then I have actually drawn it, means whole tail will be drawn. Then I need to actually keep all this game logic inside the snake bite itself is equal to zeros if condition basis, means braces are not there but block of it. And then if it actually bite itself, then it will be actually set it to 1, and if it sets to 1, then I will just print the game over on the screen. And then nothing will inside this loop will run, because the if condition gets false, and only it will wait for the quit event to be true, right? Even for quit event to occur. And then it will actually set the done is equal to true, and then when done is equal to this is set to true, then this loop will become false and the whole game will end. But what if any person wanna actually exit in between the game running? So I've also inserted the same event loop here also inside my game loop, which is actually occurring somewhat inside the loop. Where is it? So the loop is actually created outside also, but I need to actually put this loop inside the if condition, true if condition also, because this must be actually an option available for the user if he wants to end the game even before the snake bites itself. So let us actually try running the, because this is actually the game overstate, so nothing inside the if condition is running. So I can actually close this up and again run that Python file. It is running, it is giving me this game. All the statement of the print are actually printing on the console, and this is actually for the first head one. I can actually just eat the food and it will go on getting the next food item. If I go off the screen, it will come from the next thingy. And I can actually go for the that block to be eaten up. And okay, so I can use the arrow keys here because the key codes are actually being inserted on the basis of the arrows. And if I go upwards, it will not go beyond this one, because the actual canvas which I have used is actually 40 by 400 by 400, and the space above it is actually being used for that score printing thingy. And it will actually keep on doing this. And one thing more to actually show that I need to actually print a black rectangle over the screen before printing the snake and the food item, so that it actually refreshes everything, and print it again and again so that it looks like a animation thingy. And as you can see, the score is actually updating accordingly. So one thing we can do is actually we can actually insert the walls or the mazes like thingy, so that and also we can put the collision detection thingy, so that it becomes a bit more harder. But this is my first game built in pygame library. So it is actually a primitive one just to explain the logics to be implemented while implementing a game. Means we have a game loop which is actually running with the while condition. Here we have a screen object, we have different methods for printing the rectangles or say shapes over the screen. And whenever I will actually bite myself with like this, the head collides with the tail, so nothing goes off but just this print game over prints over this command, and then a game over actually prints up here. I can actually do what is actually just remove this score from here in the last iteration of in the else condition, and I can clear off all the things like by just calling the flip function, and then I print the game over with the score here. But those are for the additional purposes. And what you can do is actually add the logic to add the walls inside this game, so to and also set up some levels thingy, and also make a class like thingy, because this is actually just a procedural way of doing something in the very less time. So you can actually implement it with class thingy, so that you can implement the various levels with the reusable components. And that's a basic initiative. Thank you for watching the video.